Okay, so the next topic is adjacency list. So we know about linked list. If you familiar with C programming, then you know what is this linked list mean. And of course, in the first, first two topics. In the linked list topic, we have discussed what are this linked list means, and we need that data structure to represent graphs as well. Okay. So adjacency list is also a linked list, but if we consider it more specifically, then adjacency list is a pointer linked list because it contains the starting link of uh, another linked list, which makes it as a pointer linked list. So I know you didn't get what I'm saying right now. Just remember, for now, adjacency list is a pointer linked list. Sorry. So, or else someone can say that it's a list of lists. That list contains another list inside of that list. Okay, that's why it's known as pointer linked list. Okay, so a linked list is like this. Uh, so you most probably you know how to represent a linked list. So this is just a graphical representation of a linked list. So in here we have four elements, and each element is uh, connected, therefore it makes a linked list, and at the end point it points to the null pointer which represented the end of the linked list. Right. uh, so what is a pointer linked list? So this is the pretty much essential thing that you have to understand. So pointer adjacency list is nothing but a linked list contain other starting pointer of other linked list. Okay. Yeah, I have done some mistake, I think. Contains starting points of other linked list. Right? So pointer linked list is like that. So this is a one linked list. So the starting pointer of this linked list contains over here, and this is another linked list. So the starting point, or let's say a head pointer, or let's say a start node, contains over here. Normally this is not a node containing, but it's a pointer actually. We are containing a pointer over here because pointer points to a specific node. Therefore, if we store the pointer, then we can points to a what? Then we can define what is the linked list we have pointed to. Okay. So this is another linked list. So the starting node of this linked list is also contained over here in another linked list. The starting point or head point or pointer is contained over here. That is why it's known as a pointer linked list. So I think the pointer linked list is clear now. If you are not clear, then simply imagine a list like this. Okay, so this list contains another sublist like its element, like this. So this is a one list, and this list is a member of this major list, and they are could having another list like this, and this list is again a member of this main list. So on like that. There could be having any number of lists inside of this main list like this. Okay. So if you understand it in a graphical manner, then this is better. But if you are familiar with linked list graphical representations, then this representation is better. Okay. So basically this is how we are representing uh, a pointer linked list by using graphical notations. Okay, but when it comes to programming, it is kind of different. Okay, this is the exact same thing that I have been shown you before. This is in a horizontal vertical manner, but this is in a horizontal manner. Okay, so in here we have this graph 1 2 3 4 5. There are 5 vertices and 5 edges, which makes an undirected graph. Then this undirected graph can be represented by a linked list like this. So what as you can see, these red numbers representing the main vertices. 1 means 1, 2 means 2, 3 means 3, so on. 4 5 is there. Now imagine what are the vertices that are connected to the first vertex. So as you can see over here, it is clear that 1 is connected to 5, 1 is connected to 2, 1 is connected to 3. So all the connected sorry, all the connected vertices of another vertex is represented like this. So as you can see over here, 1 is connected to 2, then 1 to 2, then 1 is connected to 3, then 1 to 3, then 1 is connected to 5, then 1 to 5. Right? And it doesn't mean that 2 is connected 3 over here like this. Okay, it is connected to 2 to 3, but according to this representation, it just means what are the adjacency vertices of 1. Okay, so what are the adjacency vertices of 1, 2, 3 and 5? Likewise, what are the adjacency vertices of 2, 1 and 3? Then 1 and 3. What are the adjacency vertices of 1, 2 and 4? Then 1. Adjacency vertices of 3. Those are 1, 2 and 4. Then 1, 2, 4. Likewise, 4, then 3, 5 were adjacency vertices. Then 5, 1, 4 are adjacency vertices. Okay. And what are these null pointer means? Basically the end of the array. So I'll specify like this: end of the, not array, sorry, end of the linked list. Okay. And what is this not mean? Basically the beginning of the linked list. Actually it's not this box. It is better if I specify it like this. Since it's a linked list, the beginning represented as a pointer, then this pointing arrow is represented at the beginning, then end represent this null pointer as well as. Okay. These beginning and ending procedures are pretty much essential because in later when it comes to C++ programming, we are using these some of the we will be using some of the standard library functions to represent our linked list in C++. That's why I specify beginning and ending in here as well as. So what you have basically understand is when it comes to adjacency list, we are representing our adjacency vertices like this. Adjacency vertices like this. So basically this is the main adjacency list which contains pointers of another list. So these are sub list that contains the adjacency vertices. Right? So that is how we represent adjacency list. Okay, so implement the undirected graph using an adjacency list. So this is very essential topic. So let's move on to the programming part. So I'll remove the previous code. Then I'll include our IO stream. So this is our standard library. Now we are going to use a list. Therefore we need to include a specific library for list. So it is basically include list, and we need to specify our namespace. We are using std namespace, and our int main function is over there, and we need add edge function, of course. So it contains int u and int v, and it is not necessary to initialize as a int, but we can represent it as a void. And another function display, let's say adjacency list. Okay. So now if you're familiar with list, you know how to how to define a list in C++. So it is like this. First we have to specify our data type, so it's a list. So what type of list? The type is integer. Okay, so it just directly creating a list, but this list must be contain sublist inside of it. So I think you get the idea. What I'm saying is, see, if you specify list as list int, then it just basically creating a list like 1, 2, 3, then 4, 5, like that. But now we need to specify a sublink list inside of this linked list as well. So basically you have to use the pointer linked list like this. So this must be contained define max of 100 like this. Okay, so now we can represent any amount of, any amount of means max is 100, so we can represent a sub adjacency list inside of this main pointer list. So I can specify this data type as a global variable, but in this example I'll show you how do we deal with parameters. So it will be more it will be easier for our later stuffs as well. So now I'm going to use a parameter over here. So it's basically int adjacency list. I'll name is at adj. Now it's a pointer adjacency list. Okay. Now how do I add edges over here? So basically we are using this adjacency list, and to youth position we push back B. Since it is undirected, likewise we need to push U to V position, push back U. Okay, like this. So I know you now a bit of confused. Okay, so what is this push back means? What is this ADJU means? Why did we specify our linked list as a pointer linked list? Now you must be confused. So let me explain this one. Okay. So since I don't have any, I have to use this one. Okay, that is the only option. Okay, so imagine now we want to represent this linked list, but when it comes to linked list data structure, we can't derive it like this, like vertically and horizontal. We are using basically a pointer in this one. So how do we specify that? So first we are representing what is the edge we are pushing into. So it is basically like this. So 1, this is 1, and what are the sub elements we are pushing into this list. So I don't think this is a very good way, therefore I'll just use this PowerPoint as well, because Paint is not efficient way to do that, right? Okay, so let me quickly create a new slide. Okay, so first I initialize this 1. So imagine this is 1. Okay, so now we need to enter this 2 to 1, which is because this is a adjacency vertex. So how do I do that? Simply push back that value to 1 position. So it will be like this. That's why I specify my function like this. So basically add u means, let me show you again, add u means 1, so u is 1, and b means 2. So adju means this main box. Imagine this is the main box, and pushback v means we are pushing a specific value to inside that box. Okay, so we are pushing 2 to the first box. Okay, so what is the next adjacency vertex is 3. So how do I push 3 to first? Basically push back. So it will be incremented its size like this. Since it's a pointer linked list, it can be dynamically adjust. It doesn't matter. So we are pushing back 3 to inside this box. Likewise, we need to push back 5 to this box. Okay, so now all the adjacency vertices of 1 is successfully represented. Now we declaring another box to 2. Okay, so it will be like this. Initially it is like this, then we are pushing 1 to its back. Since it's empty, the pushback will be the first element. Then again we are calling pushback, so the 3 will be inserted to its back. It won't be inserted this one's back. Okay, it will only inserted this second box back. So likewise all the elements will be added to their specific location, only their specific location. Okay? So it is pretty much very organized. So basically it creates a list of list. So that's why I specified this function like this. So now I think you clear what I'm saying. Okay? So now I can simply call this function, and we are passing our adjacency list. Now we can pass our values. So 1 2 is 1 edge, 1 2, and if I copy my function like this, there are 5 edges. 1 to 2 is there, 1 to 3 is there, 1 to 5 is there, then 5 to 4 is there, then 3 to 4 is there. Since it is not directed, we can simply use like this, because 1 2 and 2 1 is representing all over here. Okay, because first it will be pushed to youth position, then it will be pushed to the weak position. So 1 2 is over there, as well as 2 1 is 2 1 should be over there because it's undirected. In this function it will be created, because when you are saying 1 to 2 first line, it will push 2 to the first box, then it will push 1 to the second box. Okay, then likewise when you are calling 1 to 3, first it will push 3 to first box, then it will push 1 to third box. Okay, like this. So what I am continuously saying, box means it's a specific place of another list. So in order to get some idea, in order to get some clear idea about what are these pointer linked list means, I just use the word of box. Okay, we are not calling box when it comes to data structures. We are specifying those types of things as pointers. Okay, so that is how pointer linked lists are created. So now I think the adding function is completely done. Now we have to only do is to displaying function. Okay, so there are several things that you have to know when it comes to displaying a pointer linked list. Since it's a pointer linked list, we have to some identifier to point what types of box that we are pointing to. Okay, so if we are considering this first box, then there should be an indicator to point this box. Then we can go inside that box and go all over its element, like 2 3 5. Then again we need again to indicate our second box. If we indicate our second box, then we can go inside of it, then we can go the elements inside of that box as well. So likewise this process happens continuously until it reaches to the end of the linked list. Okay, now I think everything is clear. So the first thing is we need to declare a pointer. So I'm using list in. So in order to declare a pointer, we can use this built-in standard library called iterator. So iterator, I'll name it as a PTR. So as well as we need two for loops, because first we are considering outer loops, then we are considering inner loops. That's why I need two for loops. So first loop is simply the same thing, because we need to continuously go 1 2 3 4 and 5. So it is the simply basic for loop int I v I plus plus. Okay. My neighbors are shouting. That is kind of annoying, but we have to do like that. So we need to declare how much vertices we are going to cover up. So it is better I declare another variable here as well, int vertices. So in this case it's 5. So we are getting our vertices like that. Now we have to use our pointer. So since this for loop has been initialized, we can go our boxes like that. Okay, again I am specifying this as a box for understanding purposes. Okay, from now on I'll indicate that box as a pointer. Okay, so when I'm saying pointer, if you can't understand it, then think it as a box. Okay, so first I can go all over this outside linked list, then I need to specify a pointer to inside that list. So since I'm initialized my pointer like this, so ptr equals to the beginning of Okay, so I have to pass my adjacency list as well over here, otherwise it doesn't know where I am searching for. So I can point to this adjacency list, ith position and the beginning of it. Okay, then I can go through all over the values until uh, it reaches to that specific pointer's end pointer. Then since every iteration I incremented my pointer in order to point to the next pointer. Okay, so what I've been done is, so imagine our first loop. Okay, so the first iteration I equals to 1, so it points to this first position. Then PTR means adjacency list I begin pointer, which means now adjacency I means this position, then begin means this position, so it is indicate 2. Okay, then in each iteration it increment the pointer, which means first is point to 2, then it points to 3, then it points to 5. Now he reaches to the end of the inside adjacency list, so it should be a termination point. That's why I specified this condition like this. Okay, so after it reaches to the end point, then we are go outside of the inside for loop. Then outside for loop will be incremented by 1, so it will be I equals to 2. Now PTR equals to adjacency to beginning, which means this one, it points to 1. Then each iteration it increments the pointer, then it points to 3. Now it reaches to the end of the inside linked list, then it will go to the outside for loop and increment it. Now it's I equals to 3, so on. This process will happen until it reaches to the end of the all and every linked list. Right, so that is the process. So I'll just simply see out I like this, so we can get what is the pointer we are calling, pointer we are pointed to. Since we use pointers to indicate our inside linked list, we should specify our value like this. So this star means to get the data of this specific memory address. Okay, I think you know about pointers. Pointers is simply a memory address of the memory. So since we are pointing to a memory address, when we are printing, we are not printing memory address, we are printing data. So since we are printing data, we need to specify our address as well as we are going to print the data of that memory address, the data that contains that specific memory address. That's why we are using this star. So star pointer is basically data, right? And just simply put a space over here, and each for loop is out ended. Again, what happened? Ended. Okay, like this. Those are pretty mistakes. Okay, now I can compile. Okay, there are several mistakes. Include I don't know what is the okay, that's the thing. When I'm passing parameters, I haven't specified it as a list. Okay, so that was my mistake. Sorry about that. When you are passing a list, you should be initialize it as a list. Okay, otherwise it won't be passed. So in here also it should be passed as a list. Now let's compile. There is another error. I don't know why it say like that? PT could not convert PTR from yesterday list in iterator. Okay. Okay, we haven't specified iterators as well. So hash include iterator. Now let's compile. Okay, there remains. I don't know what is here. I have done distinct iterator as a PTR. Okay, I know there. So when I am specifying this, it should be contained in space. It should be like this. So now if I compile, it will be compiled like that. So I made those types of errors. Sorry about that. Okay, now I can call this display function and pass in this adjacency list. Like that. And compile. Okay, adjacency list. Okay, I should pass my word discount as well. Compile, no errors, run it again. So this is our adjacency list. So if we go to our linked list representation, so 1 contains 2, 3, 5 as adjacency vertices. It contains 2 as 1, 3 should be there. 1, 3, 1, 4, 5, 3, 1, 4. So why it doesn't contain 2, 3 and 3, 2? Probably I shouldn't specify that. See, I haven't specified it. So that's the case. So 1, 2 is there, correct. 1, 3 is there, correct. 1, 5 is there, correct. 4, 5 is there, correct. 5, 4 is there, correct. We missed 2 and 3. Sorry about that. So 2 and 3 should be there. Now compile, run. Okay, so 2, 3, 5 is there. 1, 3 is there. Then 1, 2, 4 is there. Then 3, 5 is there. The order doesn't matter. Okay, if it is 5 or 3, 3 or 5, it doesn't matter. We are only declaring the adjacency versus. Since we are declaring adjacency versus, there shouldn't be a specific pattern. Okay, it should be 1 to 3 or 3 to it should be 5 3 or 3 5. It doesn't matter. And 5 1 4 is over there as well. Okay, so this is basically how do we represent adjacency list by using by using the C++ program. Okay, so this is how do I call. And if you are not clear what I'm saying right now, maybe you can go all over again this video, or simply you can see some resources. Okay, anyway, I'll put this code as in my description, so you can download it as well and check what types of mistakes or what types of things you have done if it is not executed correctly. And yeah, that is pretty much everything about representing undirected graphs by using adjacency list. Thank you.